I can say 2 pi instead of 360, put an n on there, and say every integer. Alternatively, I could say 2 pi n, where n is an element of the whole numbers, and this would imply there's no negatives, but maybe we say a positive or negative in front. We can start to make comments like that, but they essentially mean the same thing. There are 2 try questions to determine coterminal angles for 150 and for 280, but I want to slide on and talk about the last bit of today, arc length of a circle. The arc length of a circle is talking about a portion of the circumference. So if I were to draw a center and a slice of pi and define a portion of the circumference, a crust, there's a few letters that define parts of this shape. There is a radius that helps define the size of the circle, and there is a bit of an arc that defines the distance traveled on the outside. There is a theta that helps define the spread of the arc, again based on r, and these 3 things are interrelated in one formula. The arc length, or the portion of the circumference of a circle, is a formula where a is your arc length, theta is your angle in radians, and r is your radius in whatever units you'd like. You've actually seen this before. If I were to ask what's the full distance around a circle, most people would say, well, that's the circumference. What's the formula for the circumference of a circle? People would say it's 2 pi r. You didn't know it at the time, but the 2 pi is referring to the angle of a full rotation in the radian unit. That's your theta r. Theta r. If this is degrees, the formula doesn't work and you have to convert. So 2 examples. Determine the arc length of a circle with a radius of 6.7 centimeters and a central angle of 130 degrees. So we'll call that about 130 degrees, and determine the arc length is the question. So our formula says that the arc length is theta times r, and the theta, the one mistake people will make is they'll just write 130 and they'll get that wrong. So we will have to do a little bit of a conversion, but the radius can go in as a 6.7 centimeters. So we do have to convert that theta. We'll do this on the side and say that 180 degrees is pi radians. If we know 130 degrees, how many radians is that? Pi slides up here, and it looks like a 130 pi over 180. All of that is really just one massive number, and if we punch that all into a calculator, what comes out is 15.2 centimeters, a realistic number considering the radius. Imagine punching in 130 degrees times a 6. Would that number make sense considering a 6.7? Our last question for our first lesson is asking about the central angle. So it's asking what is the angle if we know the arc length and the radius. In our formula, we can rearrange this to say theta is the arc length divided by the radius. Arc length is 13, the radius is 5, and if you divide 13 by 5, you get 2.6. The number seems strange, but 2.6 is referring to the amount of radians. Does that number make sense? Maybe. 2.6 radians, if we kind of compare it to how much a full rotation is, let's see how we can compare this to 2.6 radians. We'll try to estimate that. We again know that this is about 3, this is about a 1.5, so 2.6 is probably close to 150 degrees, somewhere in there. That is our lesson for 4.1, talking about 4.1 angles in angle measures, and the next day we move on to a foundational lesson in chapter 4, something called the unit circle. Good luck.